hati gembira. Oh, pa, parirarapa, parirarapa, pa, 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 pa. Oh, buah mangga enak rasanya. Si mana lagi ya Tuhan paling ternama. Siapa saja ya Tuhan rajin
Baik, selamat datang kepada Bapak Ibu para peserta Bimbingan Teknis Sains. Hari ini Kamis 16 Maret 2023. Acara Bimbingan Teknis Sains akan dimulai pada pukul 9. Sebelumnya, izinkan saya selaku MC untuk membacakan tata tertib Bimbingan Teknis Sains hari ini. Yang pertama adalah para peserta untuk mematikan mikrofon selama acara berlangsung. Namun, dapat mengaktifkan mic saat akan berbicara atau bertanya terkait kegiatan dengan sebelumnya menggunakan fitur raise hand dan kemudian dipersilahkan oleh MC ataupun moderator. Lalu, peserta dapat mengajukan pertanyaan juga melalui kolom chat dengan format nama, _instansi, _kepada narasumber, _pertanyaan yang ingin diajukan. Peserta juga dapat menggunakan virtual background yang telah disediakan melalui kolom chat oleh panitia. Lalu di akhir acara, peserta agar mengisi kuesioner dan presensi kehadiran. Selain itu diharapkan juga para peserta dapat mengikuti seluruh rangkaian acara dengan utuh. Selain itu, untuk bimbingan teknis sains hari ini, terdapat fitur interpreter pada Zoom meeting untuk mendengarkan audio berbahasa Indonesia. Nah, cara menggunakan fitur interpreternya, Bapak Ibu dapat melihat di bagian bawah Zoom dan dapat menekan opsi tombol interpretation pada bagian taskbar bawah Zoom. Nah, peserta dapat memilih apakah akan mendengarkan dalam bahasa Indonesia ataupun bahasa Inggris. Terima kasih.
Pasti menjadi warga berguna. Burung dara, burung merpati, terbang cepat ke Tuhan tiada tara. Bilalah kita ya Tuhan suka menyanyi, badanlah sehat ya Tuhan hati gembira. sayang sayange, rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Kalau ada sumur di ladang, boleh kita menumpang mandi. Kalau ada umurku panjang, boleh kita jumpa lagi. Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange, rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Tok kecang bala gendir, tosbong angen kacang sapariuk kosong. Tok kecang bala gendir, tosbong angen kacang sapariuk kosong. Biaya listrik di masikit, manica angkat tinggalna, aya istri jangkung alit. Karangan dina pipina, tok kecang bala gendir, tosbong angan kacang sapariuk kosong. Tok kecang bala gendir, tosbong angan kacang sapariuk kosong. Manica angkat tinggalna, aya istri jangkung alit. Karangan dina pipina, tok kecang, oh, tok kecang,
Bismillahirrahmanirrahim. Selamat datang kepada Bapak Ibu para peserta Bimbingan Teknis Sains. Hari ini Kamis 16 Maret 2023. Acara Bimbingan Teknis Sains akan dimulai saat ini, yaitu pada pukul 9. Sebelumnya, izinkan saya sebagai MC untuk membacakan tata tertib Bimbingan Teknis Sains hari ini. Yang pertama, peserta mematikan mikrofon selama acara berlangsung, namun dapat mengaktifkan mic saat akan berbicara atau bertanya terkait kegiatan dengan sebelumnya menggunakan fitur raise hand dan kemudian dipersilahkan oleh MC atau moderator. Lalu, peserta dapat mengajukan pertanyaan melalui kolom chat dengan format nama, underscore instansi, underscore kepada narasumber, dan underscore pertanyaan yang diajukan. Lalu, para peserta diharapkan untuk menggunakan virtual background yang telah disediakan oleh panitia pada kolom chat. Peserta juga diharapkan untuk mengisi kuesioner dan resensi di akhir acara. Peserta juga diharapkan untuk dapat mengikuti seluruh rangkaian acara dari awal sampai akhir. Selain itu, pada acara Bimbingan Teknis Sains hari ini, disediakan opsi menu interpreter yang dapat digunakan oleh Bapak Ibu para peserta di bagian taskbar bawah Zoom. Nah, untuk interpreternya sendiri, para peserta dapat memilih dalam bahasa Indonesia ataupun bahasa Inggris. Baik, sebelumnya kami ucapkan selamat datang kepada yang terhormat Direktur Bina Teknik Permukiman dan Perumahan, Ibu Insinyur Dian Irawati MT, Kepala Balai Sains Bangunan, Bapak Ajun Haryono, STM SCM, pemateri kita, Profesor Tetsu Kubota dari Hiroshima University. Thank you, Profesor Tetsu Kubota, for attending this Bimbingan Teknis Sains. Moderator, Bapak Dr. Muhammad Nur Fajri Alfata, para Direktur di Lingkungan Ditjen Cipta Karya atau yang mewakili, para Direktur di Lingkungan Ditjen Perumahan atau yang mewakili, para Kepala BPPW dan BP2P atau yang mewakili, para Kepala Subdirektorat dan Kabalai Teknik di Lingkungan Ditjen Cipta Karya atau yang mewakili, serta kepada para peserta bimbingan teknis di lingkungan Ditjen Cipta Karya dan Ditjen Perumahan yang berbahagia, baik yang sudah hadir secara online melalui Zoom meeting ini ataupun melalui platform YouTube. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Puji dan syukur kita panjatkan kehadirat Allah Subhanahu wa Ta'ala. Karena berkat rahmatnya, kita dapat berkumpul melalui Zoom meeting ataupun YouTube pada hari ini, Kamis tanggal 16 Maret 2023, dalam acara Bimbingan Teknis Sains dengan tema Potential of Wooden Affordable Apartments Towards Zero Carbon Society. Sebelum memulai acara, izinkan saya selaku pembawa acara untuk membacakan susunan acara terlebih dahulu. Yaitu yang pertama menyanyikan lagu Indonesia Raya dan Mars PU, lalu disusul dengan laporan penyelenggaraan kegiatan bimbingan teknis, lalu sambutan pembukaan, foto bersama, penyampaian materi, diskusi dan tanya jawab, kuis atau post-test, dan penutupan. Sebelum memulai acara pertama, mari kita buka acara dengan membaca Basmalah. Bismillahirrahmanirrahim. Acara yang pertama yaitu menyanyikan lagu Indonesia Raya dan dilanjutkan dengan Mars PU. Sing National Anthem of Indonesia and Public Works March. Selanjutnya, laporan penyelenggaraan kegiatan yang akan disampaikan oleh Subkoordinator Pengkajian Balai Sains Bangunan, Ibu Rani Widyahantari, STMPWK. Kepada yang terhormat, Ibu Rani Widyahantari, kami persilakan.
Baik, terima kasih Mbak Inat. Selamat pagi Bapak dan Ibu peserta bimbingan teknis pada hari ini. Untuk menghargai narasumber kita pada hari ini, saya akan menyampaikan laporan penyelenggaraan dalam bahasa Inggris. Bapak dan Ibu yang ingin mendengarkan dalam bahasa Indonesia bisa menggunakan fitur translate yang ada di Zoom. Assalamualaikum warahmatullahi wabarakatuh. Dear Honorable Director of Engineering Affairs for Human Settlement and Housing, and also Prof. Tetsu Kubota from Hiroshima University. Good morning, Prof. And then Director within the Directorate General of Human Settlements and Directorate General of Housing and their representative, and then Head of BPPW and BP2P or their representative, and then Head of Subdirectorate and Head of Engineering Division in Directorate of Engineering Affairs and Human Settlement or their representative, and also all participants who are already present via Zoom meeting or YouTube. Good morning, everyone. Alhamdulillah, today we can gather together here and participate in the Building Science Technical Assistance held by Balai Sains Bangunan, Ministry of Public Works and Housing. Ladies and gentlemen, first of all, let us express our gratitude for the attention and enthusiasm of all participants who attend this technical assistance. We need to report several things as follows. The presentation to be delivered is about potential of wooden affordable apartments towards zero carbon society, intending to provide additional technical knowledge in order to support our works in Ministry of Public Works and Housing. And through this event, we can learn and discuss together about the potential of wood as building material to reach net zero emission, and then the usage of wood as sustainable material for buildings. And the presentation will be delivered by a very competent person in their fields, Professor Kubota, Professor of Graduate School of Advanced Science and Engineering, Hiroshima University. And the presentation will be explore new topics which in the future are expected to be applied in supporting our technical works in the scope of the development of human settlement and housing and realizing more sustainable housing and settlement. Ladies and gentlemen, today's technical assistance will be held within 1 day with a duration of around 2 hours. And furthermore, we can report for now, the participants that have joined in this meeting is around 165 participants in Zoom and in YouTube. And to conclude this report, we would like to thank all the participants who have been pleased to join and participate in this technical assistance, and the organizer team who has prepared everything so that this event can be carried out properly. And nothing is perfect, so that's this technical assistance. If there is something that is not pleasing to you, we apologize beforehand. And finally, we will ask for willingness of the head of building science, Pak Ajun, to open this meeting. And wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Baik, terima kasih Ibu Rani Widyahantari untuk laporan penyelenggaranya. Selanjutnya sambutan pembukaan yang akan disampaikan oleh Kepala Balai Sains Bangunan, Bapak Ajun Haryono, STMSCN. Kepada yang terhormat, Bapak Ajun Haryono, kami persilakan.
Dear distinguished guests and speakers, thank you for your participation on this delightful occasion. This time, allow me to read the opening speech of Director of Engineering Affairs for Human Settlement and Housing. Dear Honorable Professor Tetsu Kubota from Hiroshima University, Japan, Director or the representative from the Director General of Human Settlement and Director General of Housing, Head of BPPW and BP2P, and all the participants. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Above all, let's pray the God Almighty, who His compassion can gather us in this joyful opportunity to have a guest lecture as a technical assistance in the field of building science to all of PUPR members, as well as the other participants. Thanks to him, we can organize the technical assistance by online meeting. Secondly, I would like to welcome Professor Tetsu Kubota of Hiroshima University in our campus in Bandung, and hope you enjoy to visit Indonesia, particularly in our campus. We honor you. We are honored you can share your knowledge to us and share your experience. As may know, this event is a monthly event, and we hope many more experts from overseas can share their knowledge related to the building and human settlement technologies. Honorable ladies and gentlemen, nowadays we are facing numerous challenges in the building sector, globally and nationally. As you know, the building sector is the third highest energy consumer in Indonesia, and thus contribute to the greenhouse gases as much as its energy consumed. All the challenges lead to one important keyword: high performance building. High performance building is defined as those which deliver a relatively higher level of energy efficiency, performance, and other natural resources than what is required by building codes. There are at least three pathways to reduce energy consumption. First of all is lower the demand and use less energy, more efficient use of energy, and substitute fossil fuel with renewable energy source. This passive design would become more important in the future to reduce energy consumption by lowering the energy demand in the building sector. Furthermore, innovation and technological breakthrough are necessary in order to face such challenges. Distinguished guests, in a changing world as today, technological innovation is inevitable, particularly in the building sector. We see a lot of advanced technology implemented on the building to achieve high-performance building, from material technology to data-driven automation technology. Material technology have developed into what is unprecedented, such as a phase change material, low-A glazing, and etc. All this development lead to a single ultimate goal: reducing energy demand and improving energy efficiency in the building towards sustainable building. Despite advanced material technology, we in Indonesia have a traditional material that has been used for centuries, wood. The joint system of wooden structure in traditional building evidently resists to the earthquake. Numerous research confirm that the traditional houses, which are mostly constructed by timber, perfectly adapted to the tropical hot and humid climate and provided better indoor thermal environment. It is undoubtedly the most sustainable material in Earth. That's why the wooden material has recently been developed for high-rise building in the developed countries such as Great Britain, United States, Japan, Australia, and so on, due its sustainability. In Indonesia context, the use of timber as main building material for high-rise building is quite challenging. The market is not established yet. The raw materials are scarce due to the high deforestation. The remaining forests are considered as protected forests, while the production woods cannot meet the demand. It simply caused the price of wood to be so high that made the wooden materials suitable for high-income people only. It's indeed quite challenging to use the wooden material for low-budget apartment. Nonetheless, the wooden houses during this time are considered as semi-permanent house for poor people. Ladies and gentlemen, today we have a speaker from Japan to share with you about the wooden structure for high-rise building. I hope what he will share with us today will give us insight and more understanding about the particular topic and encourage us to think innovatively to achieve our national goal toward sustainable development. I believe there will be many things that we can learn to improve the quality of the building. Before I officially open this session, allow me to deliver my greatest gratitude to Professor Tetsu Kubota. At least by reciting Bismillahirrahmanirrahim in the name of God, the benevolent and the merciful, I hereby officially open the guest lecture and technical assistant today. I hope you enjoy the event and hope it's useful for us. Have a nice technical assistant. Waalaikumsalam warahmatullahi wabarakatuh.
Wabarakatuh.
Baik, terima kasih Bapak Ajun Haryono atas sambutan pembukaannya. Selanjutnya, mari kita akan mengadakan foto bersama. Kami persilahkan kepada para peserta untuk mengaktifkan kamera dan jangan lupa untuk menggunakan virtual background yang telah disediakan pada kolom chat. Now we will take a photo together. For all the participants, please turn on your camera and don't forget to use virtual background. And for committee, please be ready for take the photo. Okay, I think everyone is ready. Okay, first slide. Okay, second slide. And the third slide. Thank you. Sekarang kita akan masuk ke acara utama, yaitu paparan materi mengenai potential of wooden affordable apartments towards zero carbon society, yang nantinya akan dilanjutkan dengan sesi diskusi dan tanya jawab. Materi akan disampaikan oleh Profesor Tetsu Kubota dari Hiroshima University, Jepang. Paparan materi ini akan didampingi oleh Bapak Dr. Muhammad Nur Fajri Alfata selaku moderator. Berikut akan saya bacakan sedikit CV tentang moderator kita hari ini, yaitu Bapak Dr. Muhammad Nur Fajri Alfata. Jadi beliau merupakan lulusan S3 dari Graduate School for International Development and Cooperation, Hiroshima University, Jepang. Beliau juga telah meraih beberapa penghargaan, diantaranya sebagai pegawai berprestasi Kementerian Pekerjaan Umum dan Perumahan Rakyat tahun 2021, dan mendapatkan Research Grant, Science and Technology Research Partnership for Sustainable Development atau SATREP dari tahun 2021 sampai 2026. Selain itu, beliau juga memiliki beberapa pengalaman sebagai pembicara, salah satunya yaitu pada acara The Second International Design Research Conference di Aditya College of Architecture, Mumbai, India pada 18 Desember 2021. Bapak Dr. Muhammad Nur Fajri Alfata ini merupakan Perekayasa Ahli Muda di Balai Sains Bangunan. Kepada Bapak Dr. Muhammad Nur Fajri Alfata, kami persilakan.
Terima kasih, Mbak Inat. Thank you very much, Mbak Inat, for giving me such a great opportunity to chair the session with one of the prominent professors from Japan. Before we start, I would like to say hello to Professor Tetsu Kubota. Good morning, Kubota Sensei. Can you hear me?
Good morning. Yes.
Thank you very much for your coming. And for
you.
your acceptance of our invitation to giving such a technical assistance of the building science for Ministry of Public Works and Housing. Yeah. I hope you are doing well, Sensei. I know
No
now you
problem.
are in Jakarta. I'm very unfortunate that we cannot held this very nice meeting offline in Bandung.
Sorry for that.
Yeah, we did really expect to held offline so we can interactively have a discussion. But anyway, I hope this also very good for us as well. So, ladies and gentlemen, with us today we have Professor Tetsu Kubota of Hiroshima University. For your information, that he is a professor specialized in the building science. Actually, his expertise include thermal comfort, passive design and passive cooling, also life cycle energy. Maybe you can correct me if I'm wrong, Professor Kubota.
No problem.
Particularly in the hot and humid Southeast Asian. If you take a look to his publication, so he has so many and a lot of plenty of research conducted in the Southeast Asia regions, such as Indonesia, of course, Hanoi, Vietnam, Malaysia, Philippines, and so on and so forth. So currently, Professor Kubota is working with us with Fintech, with PUPR, collaborating to develop a low carbon affordable apartment in the hot humid climate of Indonesia through the research grant of Science and Research Technology for Research Partnership, or so-called SATREPS. So one of the outcomes of this project actually is design prototype of the low carbon affordable apartment. And one of the new ideas coming across to us is to use of the wooden material as the main structure or main building. So yeah, maybe as previously mentioned by the director speech that been represented by the head of Balai. So the director emphasized on the such challenges of using material, wood material in the Indonesian context. I think we can address here. And I know most of the participants are practitioners. Most of all of you have been working with so many construction projects, and maybe you can give us new ideas, some inputs, and maybe comments about this new idea. So before Professor Tetsu Kubota gives his lecture, so I'd like to remind all of you about the rule that please unmute your speaker, your microphone, I'm sorry. And if you have any question, please do not hesitate to ask by raising your hand, or maybe write them down on the chat box. And if you cannot speak English, you can use speaking in Bahasa Indonesia, and we have interpreter. He or she will interpret for us. So Professor Tetsu Kubota can understand easily your question. So yeah, and Sensei, Kubota Sensei. So actually we provide interpreter here. So if you want to listen or hear a question or something in Bahasa Indonesia, you can just click on the interpretation on the below on the screen. So I hope that make ease for you. You have 60 minutes maximum for the presentation, Sensei, and I will remind you 5 minutes before it is over. So please, yeah, time and screen is yours, Sensei.
Thank you very much.
Thank you.
Right. So once again, thank you very much for giving this very, the wonderful opportunity for me to give a talk in front of the pair members, especially me. So thank you very much. And also, by making use of this opportunity, I'd like to appreciate all the, the very friendly cooperation always you make for our project. So thank you very much for your cooperation, indeed. Okay, especially Ariel-san and all the teams. So thank you very much. Okay. So I'm really sorry for how to say not being in now London. So yes, because I went to Tikal, and I will tell you the detail later. So then now we try to construct the next experimental house. So therefore we have to go to Tegal, and then now I just came back from Tegal to Jakarta, and then a few days later, so I go back to Japan eventually. Okay, so thank you very much once again. So let me share the screen. Today's topic is quite, in a way, challenging for me as well. So this is ongoing. So therefore, I think that I cannot give you the very concrete results of this topic. So rather, I'd like to discuss and share the opinion with you, if possible. So please, therefore, just like Dr. Ariel-san mentioned, that please give your opinion rather than to just receive the information from me, if possible. This is really ongoing, the research. So the topic is, yes, needless to say, so I'd like to talk about the potential of wooden construction for affordable apartments towards the zero carbon society in Indonesia. Okay. So as Dr. Ariel mentioned, so we are now doing the relatively big joint research project, which is so-called DELCA SATREPS. So funded by Japanese government and supported by the PUPR very strongly, and Indonesian government. Okay, so the goal of this project is, as you may know, hopefully, is as Dr. Ariel also mentioned. So we now try to develop and propose the new type of affordable apartments for Indonesia. So our target is two apartments. One is Rusunawa, and second is Rusunami, the high-rise 30-story apartment. Okay, so then eventually, so we would like to propose the new guidelines in order to achieve the low carbon, zero carbon for these apartments, Rusunawa and Rusunami, together with PUPR. So that is the target of this project. Okay, so this is 5-year project. So now we are now just entered the year 3, if I'm mistaken, of the 5-year project. Okay. So just the midpoint of the project duration, right? And then as I mentioned repeatedly, I myself is the project leader of the Japan side, and then Dr. Ariel is the project leader of the Indonesian side, and then we also involve the many stakeholders from not only from the Japanese universities but also from the Indonesian major universities like ITB and ITS and so on and so forth, as you can see. And also some important local authorities, the national organization like BMKK and also Tegalu local authority. Okay, so all right, so this is the outline of the SATREPS project. So as I mentioned, so the goal of this project is to develop the new type of low carbon affordable apartments for Rusunami, Rusunawa in Indonesia towards the Paris Agreement. Okay, So then now we are doing a lot of things, as you can see here, not only building scale, but also, yes, we try to standardize in different fields also. So together with Professor Nimiya from Kagoshima University, for instance. So we also developed the standard weather data that is climate, actually. So we found that in order to standardize the building, so we need to standardize other things at the same time. So climate is a good example. So as you know that for almost all the building simulation, so needless to say, we need the good quality of weather data, right? So normally in the developed country like let's say Japan and US and so on and so forth, we have so-called standardized weather data, standard weather data, sometimes which is called TMY, right? But now, unfortunately, we don't have such a standard weather data in Indonesia. So therefore, now we develop our own standard weather data that can be used for any kinds of building simulations, right? So that is one, the climate group. Two, the human group is, yes, we are doing the same for human scale. For human scale, yes, thermal comfort standard is needless to say inevitable, very, very fundamental standard, as you know, for any kinds of building, design. But again, we don't have our own, appropriate, suitable thermal comfort standard for the tropical people, right? So now we are developing our own thermal comfort standard together with again, the Japanese different professor whose name is Sakoi of Shinshu University. Okay, so that is number two, the human. And then the building scale is in a way the most important. So we are together with the other professor from Tokyo Institute of Technology. So, and of course, together with Indonesian counterparts like Dr. Ahli and so on and so forth. So we are developing building techniques for, the low carbon or zero carbon, apartments. Right, that's number three, building group. Right, energy group is assessment group. So we need to assess our proposed building techniques in terms of energy consumption as well as CO2 emissions. So that is the role of the building energy group, number four. And five is the implementation. So after doing the fundamental studies, we need to implement into practice. Right? So we do the implementation in at least 2 steps or even 3 steps. Right? The first step of the implementation is to construct a full-scale experimental house. So this is in a way today's topic. Right? So we have already constructed one full-scale experimental house in Tegalu. Let's say Tegalu experimental house A. Okay, let's say. Right? We have already constructed a few years ago, as you may know. Right? So then now we plan to construct the next experimental house. Let's say experimental house B, let's say, soon in Tegalu, in the same site. Yes. This is going to be the, wooden structure. So this time, actually. So this is today's topic, right? So after constructing such a, full-scale experimental houses, A and B, then, we will incorporate all the research results into the, national standard, SNI. Okay, so that is the, the main goal of our project within 5 years. And then after that, if possible, we would like to further implement our idea into the compulsory building course in Tegalu. Okay, so that is the final goal of the implementation as well. Okay, right. So anyway, so now we are in the middle of the project, as I mentioned, the 2023, let's stay around here. Then, I'm sorry, this is very complicated, but the flowchart of our project. So comprising 5 groups, as I mentioned, climate, human, building, and etc. until implementation. Okay. So now we are doing the fundamental studies in different groups, right? And then we will integrate our idea into one. And then from this year on, we are going to propose the prototype design. So as you can see, right? So then, yes, at the same time, we will construct the next experimental house B here. Okay. And then eventually we will incorporate all the idea into the guidelines SNI. So that is the end point of the project. Okay. So anyway, so let's talk about, yes, today's topic. So experimental house B, yes, wooden, yes, the affordable apartment. Okay. So we are now interested in wooden structure. So as a future, yes, the Rusunawa apartment. Why wooden structure is so interesting? But yes, as Mr. Jun also mentioned, now yes, the wooden high-rise structure is something boom, right? In all over the world, right? Especially in Europe. And also, yes, Japan as well. So now the many wooden high-rise, the buildings are being constructed, as you may know, right? Something boom, right? So now the highest wooden structure can be as high as almost 100 meters, as you may know, Norway, for instance, and even Canada and so on and so forth, as you can see here. So these are the latest example of highlights, the timber structure, as you may know, right? Why, I think that, yes, most of you are already aware of the importance of the timber structure for low carbon or even zero carbon, but and try to understand once again why, yes, it is important to think of yes, timber structure as a potential, option for the low carbon. Right. So this indicates that, yes, life cycle of a building. Right. So everyone knows. Right. So during the life cycle of a building, so we consume so much energy and emit CO2 and etc. Right. As you know, from the extraction of the raw material, so that's the starting point, and after that we assemble some some products, building material, and further assemble a building. That's a manufacturing phase, right? After that, this is not short. This is the longest, the period. Yes, the operational phase. So during the operational phase, I mean after the construction, needless to say, we use the building, right? This is very long period, so 20 or 30 years, depending on the building, needless to say, right? And then during this phase, at operational phase, we consume so much energy, as you know, the most energy, as you may know, in most cases. And after that, we demolish the building. And then even during the demolition, so of course we consume energy and emit CO2, right? And even until the dump site. Some of the material may be reused, as you can see here. Right. So then, in that case, that one goes back to the the manufacturing phase. Right. So anyway, so this is the the whole life cycle, lifespan of a building. Right. And then, as I mentioned, so let's summarize the life cycle energy and life cycle CO2 once again. So this is called operational energy. Operational energy is this, right? The energy used during the operation. So when we use energy, when we operate energy, so needless to say, we consume so much energy for instance, for air conditioning, for instance, and then for cooking purpose, for lighting and appliances, and etc. Right? Especially in the case of Indonesia, tropics. Nice. As you know that we consume so much energy for, yes, the air conditioning, right? Cooling, especially space cooling. Yes, once you use air conditioning, we consume so much energy, electricity for, yes, air conditioning. So that's why we now try to promote passive cooling as much as possible in order to reduce the energy consumption, especially for space cooling, right? Cooking is also, yes, it's a big consumer, as you may know, right? And then lighting and also, yes, appliances, as you can see. So this is so-called, of course, as you know, that, yes, operational energy, right? And then today's topic is in a way rather, yes, embodied energy, embodied energy is, as you know, is the energy used, consumed during the, yes, production of the building, right? So during the production, when we assemble the building, produce a building, we consume energy and emit CO2 emissions. So that is called, yes, embodied energy, right? So of course, in most cases, as you may know, as I probably mentioned, operational energy is bigger than that of the, the embodied energy. But the embodied energy is also, it's not negligible, right? It's a huge amount of energy is also consumed during the, yes, production phase, manufacturing phase, right? That is embodied energy, right? So yes, especially, this is a bit important point, as you may know, right? Especially production of a steel and production of a concrete, yes, consume so much energy and emit, huge amount of CO2, right? Brick as well. Why brick, consume energy? Because we need to burn, as you know, right? When you use the, burned, brick, needless to say, we need to burn the brick. And during that process, of course, we need to consume so much energy, right? And therefore emit CO2, right? And then the concrete as well. So during the process of the concrete manufacture, so we consume so much energy. So therefore now, that some of the professor try to find a new type of concrete, as you may know, that using the renewable material and so on and so forth and something, and then right, try to reduce the energy consumption for producing concrete, for instance. Steel is also, so I think everybody can imagine that, needless to say. So during the production of the steel, we consume so much energy. Heat is needed, and right, so you need to burn the heat, some fuel, and also transportation. We need to transport the, the steel from, let's say, China to Indonesia, for instance. That's also consume energy, needless to say. So therefore, anyway, I'm sorry. So important is that especially steel, concrete, right? These two are the, the normally the biggest consumer of energy, and yes, in terms of the embodied energy. Okay, so then now, so therefore now, I'm sorry, now I'm talking about the why, yes, now timber structure is now, the highlighted, right? So this is the reason, right? So in other words, as long as we use steel and concrete, it is very, very difficult to achieve the low carbon, especially zero carbon, right? Because as I mentioned, the production of steel, production concrete consumes so much energy in particular. So, right. So therefore, yes, now the timber is now can be one of the, the very potential, the option for achieving the low carbon and zero carbon, right? Because if we construct a nice, timber, high-rise structure, for instance, we may be able to avoid using steel and concrete much, right? So that's why. So now the, yes, timber structure is now highlighted, right? So yes, these are some of the example of in Tokyo, right? Even in Tokyo, right? Maybe most advanced country is now is not in Japan, but the Europe and so on and so forth. Yeah, in Europe, yes, I think we can see the more example of timber structure, high-rise timber structure, but in Japan as well. So we have some, good example in Tokyo. Yes, I myself and together with Dr. Ariel, so we yes visited some interesting example of wooden structure in Tokyo quite recently. So this is one of them, so-called flat woods. So this is basically the apartment for staff of Takenaka Corporation, which is one of the biggest construction company in Japan. Right. So they construct this apartment several years ago. And as you can see here, so this is not complete, the timber structure. It's a composite. So the main structure is still, yes, is used by made of yes concrete. As you can see here, the floor slab and so on and so forth is concrete. But the rest is yes is made of wood, right? As much as possible, right? And then in Japan, as you may know, that the fire protection is strongly restricted, as you may know. So therefore, it is very, very difficult to, how to say, meet the required building codes and standards for fire prevention, right? And then they developed the new, the structure system in order to, how to say, improve the fire prevention, performance. So then what they do is they insert this kind of mortar or concrete inside of the column. So as you can see here, according to them, if we do so, so they this concrete part inside of the column, so this can absorb the heat. So therefore, this core part of the column will not be burned, right? Thanks to this, the concrete part, right? So, so they develop this kind of some unique, structure. So in order to meet the Japanese, fire prevention standard, by somehow now, and then by using this kind of unique technique, yes, they construct this high-rise, apartment. Okay. This is another example. So the name of the building is Kitoki, constructed by not very major construction company, unlike Takenaka. I'm sorry, I just forgot the name of the construction company. But anyway, so this is also composite. I think that proportion of the concrete is bigger than that of the perhaps previous example. So that yes, as you can see here, apparently, so this the concrete frame is RC concrete, right? But the inside is wood. Then the wood part is not all, actually every 3 floors, this concrete. I'm sorry, the wood then inside is wood. Here inside is wood, and inside is wood. Right. In between, they still use the RC frame, as you can see here. Right. And then the wooden floor is this. This is floor, the plan of the wooden, floor. So yes, except for the, the columns, as you can see here, the inside is they use the floor, timber floor structure, as you can see here. So inside is therefore, except for the column, again, very, very woody. And then they try to use the wood as much as possible. Okay, so this is section 9. So as I said that every 3 years, they use the normal, RC structure, but in between, they use the, timber structure, as you can see here. So this one is quite rare case. Unfortunately, we could not visit this example because this, building is already occupied by the normal people. So therefore, we couldn't enter the building. Right. So according to the website, so this Port Plus is complete wood. Right. Even for the main structure, so they totally apply the wood timber, as you can see here. So not only floor and partition and so on and so forth, even for the main structure, they use the glue lamp and as floor, I think the CLT, and totally they use the wood for the whole part of the building. So this is Port Plus. This is quite a rare case, even in Japan.
Yeah.
Okay, so from now, I just want to share with you the ongoing research, as I mentioned, right? We just conducted very small case study together with my students in Hiroshima. So then we just calculate how much energy and carbon emission can be reduced by if we, convert the current RC Rusunawa apartment into wooden apartment. Okay, so currently Rusunawa apartment is, if I'm mistaken, it's constructed of RC frame and brick or concrete block, if I'm mistaken. So what if we convert it into the wooden structure? So how much energy and CO2 emission can be reduced? So that is the question. Okay, so let's take a look at the results. Current Rusunawa is this. Right. So I like Rusunawa very much. So this is perhaps new type of Rusunava, I believe. Right? We pick up this as example, and then yes, we conducted this case study. Right? So this is the case design. Right? So we conducted two very simple actually, two only comparison. Comparison one is in terms of building structure. So scenario 1 versus scenario 2. Right. Scenario 1 is actually the current Rusunava. Right. Yes, and the RC frame plus brick wall, right, or concrete wall. So that is the current condition. Let's say scenario 1. Right. Scenario 2 is yes, wooden structure. So we completely convert the current Rusunava into wooden the structure. Right. So timber structure. So that is scenario 2. And then we purposely use the domestic material. So that is, the scenario number 2. Okay. And then comparison number 2 is, yes, we compare in terms of the domestic material or imported material. Yes, domestic scenario 2 is, as I mentioned, we, apply the domestic material. We choose jabon. This is, as you know, that very, popular in Indonesia, and tropical tree. Actually, and jabon is good tree actually, so we can use it for even for building structure. Right. It's and then the fast growing, and as you may know, so then we just assume we use jabon for building structure. So that is scenario 2. Scenario 3 is yes, so we purposely use the imported wood material from China and from also Europe. So let's say the pine from UK or hornbeam tree from China. So this is also, these are normally used, as you may know. Right? So that is scenario 3. So then we just compare. So which is more energy consumer, or which is more which is high emission, in terms of emission and also in terms of energy. Okay. So this is my students first construct the so-called beam model. Beam is beam model. And then the number 1 scenario 1 is the current Rusunava. So as you can see here, let's say RC scenario, right? So we emulate the normal Rusunava, as I mentioned. So 4-story, as you can see here, and plus foundation, as you can see here. And then this time for wooden scenario, I mean the scenario 2 and 3. So we don't consider the foundation, but I think this is perhaps too optimistic. I think we should still consider some foundation, I believe. But anyway, in this simulation, we don't consider the foundation, as you can see here, and we convert the concrete part into wood totally. Right. So that is scenario 2 and 3. Right. Same, of course, the apartment design is completely the same, 4-story and 2-bedroom. This is inside. So yes, we just emulate, as I mentioned, the normal, ordinary, Rusunava, new type Rusunava apartment, right? And then the inside, room allocation is this, just for your information. I believe this represents the current Rusunava, arrangement. And then the left-hand side is scenario 1 is the current normal Rusunava and all concrete and the brick. And the right-hand side is our, let's say, proposal, the scenario, the timber structure scenario. So we convert it into wood totally. Okay. And then from here, I'd like to show you the results of our calculation. Right. First, this shows the quantity, the material quantity per area. Right. So the amount of material used for each of the buildings. Okay, so the gray indicate the current Rusunava apartment, right? And then this green indicates the result of our proposal, wooden structure. Okay, and then in the case of the current Rusunava, RC concrete, the brick, the building. Yes, needless to say, we use so much concrete. Needless to say, cement, sand, gravel. And as you can see here, and also we use, the certain amount of steel, right? Needless to say, for, the reinforced concrete and also foundation, right? So here is also important point actually. And then of course we use aluminum for windows and etc. And also the roof structure, I believe, and so on and so forth, right? And then we just convert it into wood. So in that case, needless to say, we don't use, concrete much, as you can see here. So that is green, scenario 2 and 3, right? And then instead, we use so much, the plaster board for partition and so on and so forth. That's why the amount of plaster board is suddenly increased, as you can see here. And then steel also, right? So we can dramatically reduce the use of steel, right? If you convert into, yes, timber structure, needless to say. So this looks tiny, but they quite, big reduce. Okay, so please remember this. And then the next slide indicates the CO2 emission, right? In terms of CO2 emission, yes, as I mentioned, steel is the, really big emitter, right? Amount is not necessarily huge. It looks not huge, but the steel production is consume so much energy and therefore emit huge amount of CO2. So therefore, in terms of the CO2 emission, yes, steel is the biggest emitter. So as you can see here, especially for the scenario 1, current loose number, right? As you can see here, yes, this is the it's the huge CO2 emission happened during the production of steel. So therefore, if you convert it into timber structure, so we will use less steel. So therefore, we can reduce CO2 emission dramatically, as you can see here, right? And the plaster board, for instance, yes, in the case of timber structure, we use so much, so huge amount of, plaster board, but these, will not consume so much energy and also CO2 emission, right? So that is also interesting point. Okay. And then this is just a summary, actually. I'm repeating the same information, right? So this is, yes, just pie chart showing the proportion of the material used for scenario 1, and this is for scenario 2, right? Wooden, the construction, right? So in the case of RC, current Rusunawa, yes, as I mentioned, steel is in the case, in terms of the volume, right? I'm sorry, in terms of the quantity, this in terms of the kg, like weight, right? Only 5%. But in the case of wooden structure, almost 0, right? But the only 5% in terms of the, let's say, quantity, but yes, as I mentioned repeatedly, that consumes so much energy and, emit huge amount of CO2, right? So 81% of the CO2 emission come from the production of the steel, right? So that's why this, right? And in the case of, yes, wooden timber structure, so in that case, only 45% of emission is caused by the production of the steel, right? So therefore, once again, the steel production and also as well as concrete production is something very important key in terms of, yes, CO2 emission. Okay, so therefore we can dramatically reduce the embodied energy as well as CO2 emission if you convert the concrete apartment into the timber structure. So this is our calculation result. So yes, we can reduce the embodied energy by more than 60% if you construct the structure instead of concrete. And the CO2 emission also, yes, you can reduce the CO2 emission more than, yes, 60%, as you can see here. And this is talking about the, yes, the comparison number 2. So what if we use the imported, wood instead of domestic wood, right? So this one, I'm sorry, this is not very accurate at the moment. I am sorry. So I believe, I think this is a bit underestimated, I think. But in theory, needless to say, if we use imported wood instead of domestic wood, yes, we will consume much more energy because we need to transport the wood from overseas to Indonesia, right? So therefore, I think this is a bit underestimated. Right. But anyway, yes, now under this calculation, the difference is not that high, but yes, this is the difference. If we use imported material, okay, we will emit CO2 slightly more. And here also. Okay, I'm sorry. Okay. This is talking about, I'm sorry. All right. This one is the comparison in terms of the embodied energy and CO2 emission, right? So yes, in total, yeah, needless to say, domestic material is much better. So as you can see here, okay, so if you use Japan, the local material, right, the embodied energy per square meter, cubic meter is this, right, 0.03. But if you use the China material, the home bean, imported from China, and then the yes, embodied energy will jump up. So by more than 200%, as you can see here. And even if you use the pine from UK, yes, still the embodied energy is much bigger than that of Japan. Right? The same can be said for CO2 emissions. So yes, so this clearly shows that as expected, yeah, needless to say, it is very, very important to use local domestic material rather than to import the wood from overseas, needless to say. Right. This is normal, right? Because we need to transport, right? And we need to process and then everything, and that will consume energy, right? So therefore, it's very, very important to use the local domestic wood material as much as possible if you wish to reduce the CO2 emission. Right. So okay, this is talking about the carbon storage, effect. Carbon storage means that as you may know that the tree forest contain carbon inside, right? Needless to say, if you burn needless to say, the forest wood, these contained carbon will be released to the sky, to the air, right? But if you still if the wood is still there, so I mean as a building, the carbon inside is stored, right? So we can store the carbon inside of the material, right? So this is so-called carbon storage effect, right? So this carbon storage effect is depending on the density of the material, actually. So, okay. So if you use Jabon, for instance, as you may know that the Jabon is fast-growing tree, it's a very good, but the density is not as high as, let's say, the pine or hornbeam tree, actually. So therefore, as you can see here, so in terms of the carbon storage effect, yes, in a way, imported material, the high-density tree like pine or hornbeam is in a way better in terms of the carbon storage effect. Right. Okay, so, but anyway, so this is the short summary of this case study, right? I'm repeating, but anyway, so first point is, as I mentioned repeatedly, yes, it is as expected. Yes, carbon emission is, if we convert the concrete, Rusunawa into the, wooden structure, timber structure, we can reduce the CO2 emission by more than 60%, as you can see here. And then also, concrete cannot store the, of course, carbon, right? Then only trees can store the carbon. So therefore, if you convert the, the concrete structure into, the timber structure, the carbon storage effect also can be increased, needless to say, by more than 10 times, right? So therefore, in order to achieve the low carbon or even zero carbon society, yes, the timber structure is a good option. One of the, maybe best option. Okay, as you can see here, that's number one, right? So yes, in terms of CO2 emission, yes, imported material is better because we don't need to transport, right, so much. And then the process, the energy consumption during the process is also less. So therefore, yes, it's better to use in the domestic material as much as possible if you wish to reduce the total CO2 emission, right? But the carbon storage effect itself is a bit different. Actually, imported material is rather better because this depends on the density of wood, as I mentioned, right? But the transportation cost is much better for needless to say domestic material, as I mentioned repeatedly. So therefore, in terms of the affordability, so needless to say domestic material is better, right? We should use the domestic material in order to reduce the cost, right? In order to achieve the affordability, yes, domestic material is the best option, right? Okay, so that is the tentative conclusion of this case study. From here, I think I just want to, share with you our new idea. So, but before our new idea, I just want to share with you the current, the already existing experimental house. Let's say experimental house A. Okay, next one is B. Right? So A is, yes, already constructed, as I mentioned repeatedly. I hope some of you already visited our experimental house. So this was constructed together with, yes, the PUPR, Dr. Ariel and the team, and also the ITB, and designed by ITB as well. So anyway, so this was constructed really thanks to, yes, PUPR, okay, and also leadership Tegalu local authority. So this is now exists in Tegalu, yes, and then the concept is this. So this experimental house is, is aimed at rather Rusunami apartment. So this target is not the Rusunami, right? So although, this building is only 2 or 3 story building, but the target of this building is 20, 30 story Rusunami apartment, right? So therefore, our assumption is the income level for this building is not as low as Rusunawa, right? The middle class, right? So therefore, we assume they may use air conditioning, at least in bedrooms, right? But the living room, I think that we hope they don't use air conditioning, right? So that is the idea of this, the experimental house, right? So this one is the living room. So therefore, in living room, yes, we hope they don't use air conditioning. In other words, they can achieve, the thermal comfort without using air conditioning. In other words, right? So our concept is this. So as you may know, so first we put the blue indicates that, so PCM is a phase change material, so that can artificially, we can change the thermal capacity of that material, right? So, so it's a chemical product, as you may know. So we put PCM just behind the, the floor slab, and we forcibly ventilate this tiny space by putting the exhaust fan, okay? And then forcibly we ventilate this tiny space, and during the nighttime, and we store the cool, the inside of the PCM, okay? So that is the nighttime situation. And then once we store the cool during the nighttime, even during the daytime, the occupant can enjoy some cool from the floor structure thanks to the thermal storage effect and PCM, right? So occupant can enjoy the cool not only through the radiant cooling effect, but also from the direct contact. So this is the topic of now that Asawa, Professor Asawa, the Tokyo Institute of Technology, is now doing together with the Indonesian counterpart, right? But anyway, in that case, yes, we will be able to achieve the thermal comfort even with opening windows. If open window, of course, indoor temperature maybe, not maybe, it's surely will be increased to the outdoor level. So if the outdoor temperature is 32, let's say, or 33, indoor temperature will reach that same level. So 30 or 31 or even 32, right? So it's very difficult to achieve the thermal comfort in terms of the temperature, right? But instead of that, yes, we cool the building structure as much as possible, especially for floor, structure, right? So that the occupant can enjoy the cool through the radiation, right, as well as direct contact, as I mentioned. So therefore, barely the occupant can still enjoy the thermal comfort. So that is the concept of this, floor radiant cooling system. Right. So yes, so as maybe Professor Asawa most probably, explain the detail of this, the cooling system in the perhaps the several months ago, I believe. But anyway, so this is the detail of the, this cooling system. Right? We conducted this kind of experiment and also simulation together with PIT and also the PUSKIN members. Yes. Yes, in not only in the garden, but also in different places together with YKKAP team. So these are some of the results, but perhaps I can skip because Professor Asawa, I believe, already mentioned and explained about the results previously. Next topic is, yes, not next topic, I mean, that's my, yeah, let's say next topic is, this is our, our research topic. Yes, we are doing the ventilation, as you may know. So still I'm talking about the experimental house A, still I'm talking about A, but anyway, so one of the important concepts for the experimental house A is natural ventilation, right? So yes, we designed the vertical void inside of the apartment. Why vertical void, actually? So I'd like to tell you again why we designed the vertical void inside, right, of the apartment. So first of all, as you can see here, so for me, this is very important information, but for you, this is perhaps very, very normal. But anyway, so we found that the most of the Indonesian Rusunami, especially Rusunami apartment, are designed, as double-loaded apartment, right? So in Japan, this is very surprising, actually. So in Japan, most of the apartments are, if I'm not mistaken, yes, rather single-loaded. Why in Japan, well, yeah, single-loaded is typical? Because that we need to receive the the sunshine needless to say, especially for the winter sun, especially for heating purpose, right? So therefore, the double-loaded is cannot be accepted by the people. So we have to orient the the apartment towards the south in order to receive the the winter sun, right, for heating, right? So that's why the most of the apartments in Japan, I can say, I think the northern hemisphere, yes, most of them are single-loaded and oriented towards south, right? As you may know, right? So therefore, for me, it's a very, very surprise to see that yes, the Indonesian apartments, are designed as double-loaded apartment, right? But interesting in a way. This is in a way no wonder, right? Because you don't need the strong, the sunshine. Rather, it is avoidable. We don't know. We don't want right to receive the heat. Right. So that's why yes, I think that rather than to orient the building towards the south, you don't need to consider the orientation much. Right. Rather, you prioritize the the how to say the area, right? The floor area. Right. You need to increase the floor area as much as possible. Right. So without considering the the building orientation much. So therefore, as a result, most of the the apartment in Indonesia, especially private apartment, the Rusunami, most of them are double-loaded. Interestingly, right?
すいません、先生。
Okay.
You have 10 minutes.
Okay, 10
remaining.
minutes. Okay. 10 minutes.
お願いします。
わかりました。Right. Thank you very much. Right. But the double-loaded apartment is actually the ventilation is it can be poor, as you may know. Right. So especially for the leeward side of the apartment, we cannot give the good cross ventilation, right? Because they, people tend to close doors, on the corridor side, right? So therefore, especially on the leeward side of the apartment, they cannot enjoy the cross ventilation. So that's a big problem actually for this kind of double-loaded apartment, right? So therefore, now we propose to design the void space inside of the apartment, right? if we design the void space in between the apartment, and then our idea is this: we design also wind catcher, at the edge of this, the piloting space, right? If so, yes, we can, give the nice, the increased nice breeze from the downstairs to the upstairs, right? That is the idea of our, the experimental house A. Our design concept is actually right-hand side, right? So left-hand side is common, actually. This is also, very, the commonly used, actually. So normally, the, void apartment, the roof part is open, actually, right? Open void. So this is common, actually. But our concept is different, close, and also, we make use of the piloting space. So that is quite new point, actually, compared with the ordinary, the void apartment, actually. But maybe because of the time constraints, I think I try to skip the detail. But yes, interestingly, in our case, that we can enjoy, better ventilation rather than the ordinary void apartment, according to our study. Okay, so yes, maybe these are some of the detail of the simulation results and also the experimental results. So if you are interested in, please just take a look at our journal papers already published in some the journal. Yes. So yeah, or maybe please tell me, and I'd like to tell you the detail later. So anyway, so yes, by making use of these, the design concepts, so we constructed the experimental house A. Okay, so this is the, the just environmental concept of for the house A. And this is the, yes, the outside. And I have just come back from this place. And this is inside. So we designed the vertical void, as I mentioned, based on the simulation results. Okay. And yes, now we are, doing the field measurement, and then it seems that yes, the void space and the wind catcher as well are quite effective. So yes, even in the leeward side of the apartment, we can enjoy nice cross ventilation thanks to this design concept. Hiroshima is here, and yes, we had the opening, ceremony before the COVID, and 2 years ago, and now yes, we are doing the measurement. Okay, so then by making use this opportunity, I think this is in a way the most important topic for this discussion. I really want to hear your opinion for this, the new idea. So this is talking about the next experimental house, B. Okay, as I mentioned repeatedly, now we are thinking if we construct this new experimental house as a infrastructure. The site is the same. So this is the exact site, the GAL, and yes. So we, thanks to PUPR, we obtained this, the huge. We can use this, huge land thanks to local authority as well. And then this is current condition, current status. Yes, we have already constructed the house A, as I mentioned repeatedly, and next to our experimental house, the Tegaru local authority already constructed the normal, yes, the Lusun here. And then they said that they are going to construct one more Lusun here. So anyway. So then I myself, together with Dr. Ariel, so we are now thinking if we can construct the next experimental house perhaps around here. Okay, right. And then here is north and here is south. So then as you can see here, north, already more very near to the site. Yes, is a coastal line. So therefore this site can enjoy the nice sea breeze from the north. Right, from the north. So this is the weather condition. So this is the sea breeze actually, especially during the daytime. So the site received the relatively strong sea breeze from the north. But not exact north actually, slightly the northeast. northeast, actually, as you can see here. And the seasonal wind direction is actually from south. So therefore, the important axis here is the north to south. This is the important axis for the building in order to receive the nice wind. Okay. But anyway, so this is the the tentative but the basic concept for the next experimental house. We now propose the composite structure. So it's not purely timber. So because we need to worry about the termite and so on and so forth, and also the cost and so on and so forth. So therefore, it's a little bit, maybe we also think it is a bit too early to propose the full timber structure. Therefore, we would like to go for timber structure.
Please unmute those who still on. Okay, thank you. Please carry on.
Okay, so this part is wooden part, right? And then the bedroom actually. So bedroom part is wooden structure, and then the core part, this part is the concrete. The structure. Right here, I just put the tree actually inside. So I was very impressed to see the the wide corridor space in the old type of Rusunawa, right? As you of course know that the old Rusunawa, they had the quite wide corridor space inside, and then the interestingly, people occupants, that often go out and then do chatting. And then sometimes they are sitting and sometimes they are taking nap, interestingly, in the corridor space. And then they establish and mature the nice community relationship activities inside of the corridor space, right? So, and then sometimes corridor space is rather, comfortable, interestingly, because, thanks to the concrete, the thermal storage effect, and also the, well ventilated. So therefore, the corridor space is sometimes thermally more comfortable than the inside. So therefore, people gather. So I'd like to, reevaluate this, nice semi-open, the corridor gathering space. Right? So we designed a relatively huge, semi-open space, corridor space, in order to, let them gather inside of the corridor. Right? And then I just put as a symbol, tree. So I put one tree at the center of the corridor, as you can see here. Right? And then this is the, if we connect, so this is the resultant, Rusunawa, right? But anyway, so of course, we cannot construct a so huge Rusunawa because of the cost constraint. So we just pick up one block, and this is the, the proposal of the experimental house, right? And then my idea is actually, so this is Malay house, as you know, right? In the tropics, so the semi-open space play an important role. Semi-open space means this kind of shaded space, right? A deep eave, and also this kind of large garden, and so on and so forth. These, the semi-open space play a role as a thermal buffer, right? And nicely reduce the air temperature, and also lead the nice winds to indoor, and so on and so forth. So therefore, these semi-open spaces make indoor comfortable, right? So then this design concept is this. Core space is surrounded by the semi-open spaces, right? So this wooden part is just like semi-open spaces, right? And then protect inside from the outdoor severe weather conditions. So that is one of the design concepts of this experimental house. Okay, and then this one is, if you are very familiar with the building science, I think you can easily understand, right? The concrete part is the indoor temperature is stable, right? Stabilized, right? Thanks to the thermal, the storage effect, right? So therefore, maybe the temperature profile inside of the concrete part would be like this, right? The daytime, if the outdoor temperature is 32 degrees Celsius, right? In the concrete part, the daytime temperature can be much lower than that of the outdoors. let's say 29 or 30 degrees Celsius, right? But the concrete part is, so therefore daytime is comfortable, but the nighttime is in a way terrible, because the indoor temperature is much higher than that of the outdoors. Outdoor can be 25 or so, but in the concrete part, the indoor temperature still maintain the high temperature like 27 or so. So they cannot sleep nicely, right? Therefore, again, yes, the concrete part, daytime is comfortable, but the nighttime is not comfortable. That is concrete part, right?
Excuse me,
Then
Sensei.
5
minutes.
5 minutes.
Sumasai.
Saya waktu
Oke.
itu tidak terlalu dengar.
Arigato.
Jaringan jelek sekali juga.
Should I stop now?
No, please, 5 minutes again.
Okay. The wooden part is, as you know, that yes, the thermal profile is, temperature profile would be like this, right? The indoor temperature, normally follow closely the outdoor temperature, right? So therefore, the daytime is quite hot in the wooden part, right? Because if the daytime outdoor temperature is 32, the indoor temperature will follow and increase to 32 or so. So therefore, it's a quite hot furnace, right? But the nighttime, yes, again, the indoor temperature will follow the outdoor. So therefore, nighttime wooden part, the temperature is quite low, right? Almost same as that of outdoor, 25 or 6. So therefore, wooden part, daytime is too hot, but nighttime very comfortable, actually, especially if you receive some breeze from outside, right? So this is important, right? Concrete part, daytime is good. Wooden part, nighttime is good, right? So if you do so, this house is perfect. I mean, the daytime activity should be done inside of the concrete space, and nighttime activity should be done in the wooden part. So therefore, I designed the living space in the concrete part, and design the bedroom in the wooden part. Right. So this is perfect combination actually. So the occupant can enjoy the thermal comfort, throughout the day, not only daytime, but also in during the nighttime. And then the corridor space also, this must be very comfortable because very, very concrete. So therefore the daytime temperature can be very low, as I mentioned, and plus they can enjoy the nice breeze from outside. So therefore, maybe the most comfortable place is perhaps this corridor space. So I hope the occupant can enjoy and not only thermal condition but also chatting. Okay, right. So then now we are interested in working with some local architects like Mr. Yushin, and Dr. Ariel kindly introduced me to this the gentleman. And as you know that they famous, he's famous architect, and he has experience of designing the Rusunawa as well Jakarta and so on and so forth. And also he's a specialist of wooden structure. So I think he's one of the good, architects for our project, right? And also I'm now, I was introduced by different person to this, the team, the NUS, National University of Singapore, needless to say. And there's one very strong Japanese professor whose name is Professor Okada. He can do the structural design, and as well as the architecture design at the same time actually. So they also have experience of designing so many good the timber structure, as you can see here. Right? He will be also involved in this design. Okay. All right. I think I'm sorry for the delay. So that's all from me. So therefore, yes, this is ongoing project actually. So if you are interested in this, the experimental house project and etc., so please join us. Okay. Thank you very much.
Thank you very much, Professor Kubota. So yeah, that's very interesting. So complete information and so on. But as I mentioned before, and also as Professor Kubota expected, we are very much welcome with inputs, comments, etc., etc. Right? Kubota Sensei, rather than maybe just receiving information or question. Yeah, before I open the session for Q&A, I'd like to inform you that the organizer will select 2 best questions for for souvenirs. So maybe I will give the opportunity for Professor Kubota to choose 2 best questions to be given the souvenir. Okay, let's move to the Q&A session. I see in the participant list Director of System and Strategy Perumahan, Bapak Edward Abdurrahman. Pak Edward, it is very honor if you can give some comment, inputs, or anything for us in order to improve the quality of the rusun in Indonesia in particular. Pak Edward.
Baik, terima kasih Pak Arif. Terima kasih banyak atas kesempatan yang diberikan. Pak Kubota, Ohayo gozaimasu. Namae wa Edward-san, Jakarta Karakimashita. It's quite interesting to hear your lecture or your presentation this morning. I follow how is to make comfortable in housing provision. As a director for the housing development, I'm following for the housing and the slum area and also low carbon island in Kitakyushu and also in the Tokyo for the comprehensive city planning in a few cities in Japan, like in Hiroshima, also in Kobe and in other cities. We have some seminar or material that you can read about low housing carbon and etc. But our concern is how we can input on the process for the planning and also the construction process. How we can put it in the beginning, the budget in terms of our TOR, so we can control everything that it is the low carbon process in line with the idea until the implementation, how we can control that one. Thank you.
Thank you very much, Pak Edward, for your concern. So please, Professor Kubota, you may respond.
Thank you so much for your very important comment. So indeed, I think that I'm not that the pure expert of wood structure, honestly speaking. I'm an expert of building science, needless to say. But if I'm not mistaken, the key point is assembling the composite material. So as you know that we need to assemble the CLT or glue lumps, but now it seems that we cannot find any Indonesian company who can assemble the enough big size of CLT. Right? For instance, we have already visited some wooden companies actually, such as Woodram in Jakarta or Kayolapis in the Semarang, for instance. So they can assemble only the small size of the CLT, such as the size of 1.2 meter by 2.4 meter or something. So this one is, as you may know, that it's not enough for the building construction. So therefore, now yes, we need to rely on the overseas, for instance, Japanese company or even China, for instance, and then we need to bring the raw material from let's say from Indonesia and then to the Japan or China to assemble the big size of CLT, and then otherwise we cannot use for the building construction. So okay, in other words, therefore the key is the assembling process, right? So if we can assemble such a big size of the building material like CLT, glue lump in Indonesia by using the domestic material, right? Then we can reduce the construction cost we can reduce the material cost and assembling cost very drastically, but now it is very costly because we need to rely on the overseas, right? So therefore, again, the key is that really that we have to use domestic material, and also we need to assemble the CLT and etc. composite material not in overseas but in Indonesia. So if we do so, I believe we can reduce dramatically the cost. Did I answer your question?
Bagaimana Pak Edward? How is any further comments from his response?
Yes, thank Pak Kubota. I just informed you yesterday we had a meeting with the DAICA. So the expert from Daiwa electronic company, we met a meeting yesterday. They want to provide the housing in terms of for the cover the disaster, how we can more sustainable with disaster. They want to use also the material, but it is from the Japan material. I asked them to do it with the local material, how we can construct that one, how we can consider the low carbon and etc. So we can implement in Indonesia. They want to also use the solar cell to reduce the energy. He said a good idea for me, but I may agree with your idea also that the domestic material is the key one to reduce the cost of the housing. Thank you, Pak Kubota.
Thank you, Pak Edward. So,
thank you so much. Thank you so much.
Thank you.
I'm sorry. I think that the NUS professor said that the Jabon can be used. Jabon is a very good candidate for the building construction material, according to him. And then I also interested in Falcata, but the Falcata is a bit too soft, and then that cannot be used as a building construction, the structure material, but only for the partition and wall or something. Maybe yes, Falcata also still can be used, but perhaps Jabon is some of the key material. It seems Jabon can be used. Thank you very much.
Okay, I hope we can discuss more details, saying we have two programs for the green housing development and also the low carbon material. Thank you, Pak Kubota.
Thank you, Pak.
Thank you so
Edward.
much.
Thank you very much. I think so. We have same keywords in order to achieve this target. So local material and also locally assemble. That is the keywords that the most important from the discussion of Professor Kubota and also Pak Edward. Thank you once again, Pak Edward, for your valuable comments.
Sama-sama, Pak.
We do really appreciate, and we do expect for more collaboration with Pak Edward as well. Thank you. Now we are going to the Q&A also. Next question. So basically, I'd like to divide into two parts. So first part, I'd like to ask you to directly ask to Professor Kubota by raising your hand, and I already seen in the chat box there are so many and a lot of the questions addressed to Professor Kubota, and I think I'd like to give chance. And I also surprisingly I also seen Dr. Agung of Brawijaya also ask something to Professor Kubota. So please raise your hand. I will give 3 questions for direct Q&A. Or maybe I just pick randomly the name on the chat box and you may speak up. Pak Agung.
Okay, good morning, Prof. Kubota. How are you? Yeah, thank you for that. I think it's very interesting. The topic is about the wooden apartment. So I also read in the chatting box. I need your opinion about the some requirement consideration about the material. What the type of the wood, how to process, and how to construct, especially Prof. Kubota say about the Japan, but I also have the idea about the laminated bamboo, because the bamboo is so many,
Oh.
yeah, so many, yeah, bamboo, and maybe the laminated bamboo can be become the alternative. So also the technology, we also consider about the mastery of the upstream and to downstream of manufacturing, because the manufacturing is more important to make the deep in construction, and also financing, insurance costs per meter, and more important is about the society, how about the perception and expectation of user. Sometimes the user in Indonesia is very unique. When we use the bamboo, is sometimes the perception is non-permanent building, so they also sometimes they reject this idea. And the last question, I want to I have question about your presentation. Why the plaster board is biggest component? Because I look in the data, in your data, is plaster board is very a big component. So why the plaster board is very big presentation of the component? Thank you very much, Prof. Kubota. Yeah, nice to meet you.
Okay. Nice to meet you. Thank you so much. I think according to my student, plaster board was used for all the partitions. So therefore, I think perhaps that was a bit overestimated, it seems. But that is the reason why plaster board was used so much. Okay. So anyway, so yeah, thank you very much for your other comments also. That's also very important and something to do with the previous important comment as well. But anyway, so yeah, the bamboo, I also very interested in actually. That can be used, especially I think that may be used, my idea is for the roof structure, for instance, and also at least for the shading device, perhaps bamboo can be used for something. The good thing is fast growing, right? And then the durability also there. I think I'm also interested in actually. So thank you very much. And then important is that actually, yeah, in a way that yes, acceptance from the public is, perception is so important, needless to say, right? So okay, this is something to do with the manufacturing actually, right? So now, why the Indonesian company do not produce the big size of CLT, for instance, and glulam? So this is simply because there's no demand. Right? That's a very simple actually. So as you know that if demand is there, of course, private company will follow and produce the products, right? So in other words, if the demand is no demand, less demand, of course, they don't assemble, needless to say. Everything depends on the, needless to say, demand, right? Perception, actually, right? That's a very important point, actually. So in other words, if we can increase the demand, then automatically, yes, I believe that the private company will follow, right? So all we need is to improve the demand, right? Improve the perception, right? So that is the very important point. That's why we need to do very high quality pilot project, right? So that we can show, okay, wooden structure is not bad, right? And also comfortable. We need to show it to the public, right? So that's that idea, honestly speaking. So therefore, this time in this pilot project, most probably very costly. We need to rely on the Japanese company and overseas. So therefore, cost is very high. But in a way, that's not the matter, right? As long as demand will become high, demand is increased, cost can be reduced, right? So therefore, as a pilot project, we don't need to worry about the cost, right? In a way. Rather, to construct a good quality of example, and so that we can improve, we should improve the perception of the people, as you said, right? If so, yes, the private company will follow, I believe.
Okay, thank you. Since we have so many questions, so I
Oh,
think I
yeah.
also need to pick
Yes.
some of interesting questions.
Mm.
May I invite, I don't know, Mr. or Miss Gaisani from BPPW Jawa Timur? You have a very interesting question. Maybe you can ask directly by yourself. Apakah hadir? Oke.
Iya Pak, apa
Oh, ya, thank you.
terdengar dengan jelas?
Ya. Ya,
Ya.
silakan.
Iya, ya. Pertanyaan saya seperti Alfata ya, karena dalam tujuan mengurangi emisi karbon begitu. Cuma dalam penggunaan kayu ini kan nantinya pasti akan menjadikan permintaan kayu itu meningkat dan sangat besar gitu Pak. Nah itu apakah pemerintah sudah mempertimbangkan efek permintaan tersebut karena dari atas permintaan kayu yang besar itu kan juga akan berdampak pada penebangan pohon yang dilakukan secara masif gitu Pak. Nah itu kan juga dari penebangan pohon itu bisa menyebabkan kerusakan lingkungan juga gitu. Nah itu apakah pemerintah sudah melakukan rencana strategi untuk memperhitungkan dampak tersebut seperti itu Pak? Terima kasih.
Baik Bu, ini pertanyaannya saya agak ini kepada Profesor Tetsu Kubota atau ke pemerintah ini? Pemerintah kan kita sendiri juga ini. So,
ya sih Pak, atau
okay,
mungkin dari
let's hear the opinion of Professor Kubota about this issue. So,
ya,
I think you already understand,
ya, Pak.
Professor Kubota, that she is really concerned about the effect of the high demand of the wood material. If the demand of wood material increase, consequently, there will be, how to say, massively wood logging.
Understand.
While we are now trying to maintain the remaining forest as a protected area. So, what do you think about this? About her concern?
Yeah, thank you, Raj. That's of course very, very critical, the point, right? So I listen to the translation. I think the translation is very good, actually. So thank you very much, actually. So very the correct translation. So yeah, that's an important point. Actually, I'm today talking about only so-called demand side, right? Of course, we need to discuss the supply side at the same time so that we can discuss the sustainability, needless to say, right? The important point is this, actually. So we should not use the natural forests, right? So that's very important. We should distinguish the natural forests and, the artificial, the plantation, right? So, okay. So if we use the natural forest, whose lifespan is very long, for instance, the 40 years old, or 50 years old, or 100 years old trees, for instance. If so, if you use this kind of old, very, nice, beautiful trees for construction, yes, this will lead to result in the deforestation, 100%, right? But if we use the artificial plantation, right, which we plant artificially only for building construction purpose, right? If so, we can maintain the sustainability, right? So that's a very important point, right? And then we should not use such a, the long life trees, right? We should use, the, first growing trees like Falcata and also the Jabon, for instance, right? Because I know that we can grow the Falcata, for instance, very shortly, 3 or 5 years, for instance, right? So if we plant Falcata and then use it for the construction, and then if you do the same circulate, right, we can maintain the sustainability, right? But if you use the old matured tree, let's say, whose age is 40 years or 50 years or even 100 years old tree, for instance, of course, you cannot maintain the sustainability, right? So this means that first of all, you should distinguish, right, the natural forest, conserved, natural forests and artificial plantation for, building construction, right? We should distinguish, and then we should plant the artificial, the first growing trees, forest, and only for the purpose of building construction and use it. If so, we can maintain the sustainability. Right. So we did it in Japan, as you may know. We planted so many cedar trees in all across Japan, during the high economic, boom period, actually, during from 1970s or 80s, right? And then we use it actually for the building construction, right? And still we maintain the natural forest, besides, right? Right. So therefore, you can do it. You can plant such a, the first growing trees on top of the natural forests, while conserving the natural forest, actually. So if so, we can maintain the sustainability. Thank you very much for your nice question.
Okay, thank you very much, Bu Kaisani, atau saya manggilnya Bu Kaisani ya. Thank you, Professor Kubota, for your answers. So now I will invite one more person to ask directly to you, Prof. Kubota. Ivan from Balai Sains, you can ask directly. This is also good question and good issues to be considered, Professor Kubota.
Ya Pak. Selamat pagi Pak Kubota. Saya Ivan dari Balai Sains Bangunan. Mau menanyakan Pak, wooden struktur itu memiliki embodied energi yang lebih rendah dibandingkan baja, besi, dan beton. Tetapi di Indonesia memiliki iklim lembab sehingga bahan struktur dari kayu itu rawan rapuh maupun dimakan rayap. Nah, bagaimana untuk menghindari hal tersebut dan meningkatkan umur hidup struktur dari kayu itu Pak?
Okay.
Izin Pak Prof.
Okay, can you catch up with the questions?
So, I'm sorry. Thank you, Roger. Now I'm listening to the two voices at the same time. Actually.
Okay, so basically his questions.
Overlapping. So can you translate briefly?
Yeah. So basically his question about despite the wood structure has lower embodied energy, however, Indonesia has a very humid climate, and that will be affect to the endurance or durability of the wood structure itself. So in terms of how to say fragile, fracture, and also some termite problem. So
okay.
What do you think about this issue? Yeah, this is also concerning issues of the wooden material. Thank you.
Yeah, we need to consider. I think we need to consider. That's a very important question, actually. And then if I'm not mistaken, as I mentioned, that I am not the pure expert of timber structure, but I heard that there are typically two ways to prevent the insects. One is the chemical method, as you may know that we inject some chemical to the wood, and then we can protect from the insects, so termite. And then second is physical protection. So for instance, we put some of the net on the building structure so that we can physically protect the wood from the termite. So if I'm mistaken, so these two methods are typically used to prevent from the protect from the insects. And then the third is yes. So therefore, purposely for the foundation part and also the ground floor. Yes, I think it's better to construct it by using the concrete. I think so. That's the current how to say the idea. So in order to prevent, I think better to how to say we should the soil wood part to touch the ground floor at least. I think we should apply the concrete RC for the ground floor in order to avoid direct contact with the soil. That's true. Anyway, the durability also, yes, it's a part of research. I think now we need to see how long what will become of the lifespan of such a timber structure in Indonesia in the tropics if we use such a tropical tropical trees like Falcata and also the Jabon. That's a part of research, and that's a very good question in a way. So my humble strategy is, so therefore replacement is very important actually, right? Because now we are talking about the composite structure, that some part is concrete and some part is wood, right? So then so perhaps the durability is different. Concrete part can last, let's say for even 100 years, right? But the wooden part is, of course, the durability is different, right? So therefore the maintenance period is perhaps different, right? So in other words, especially for the wooden part, every, let's say 30 years or so, we need to replace perhaps. So therefore, I think better to design such a replaceable, building is much better. So therefore, I just insert the wooden part into the concrete part so that we can easily replace the wooden part anytime. Right.
Okay.
So but anyway, so I'm sorry, this is not the clear perhaps answer. So first of all, this is still the part of research, but durability is really important, needless to say. So therefore, at least I can say that the replacement is is quite important.
Okay.
Thank you very much.
Understandable. Sensei, thank you very much. Actually, now we have only approximately 15 minutes for Q&A. So I just obtain the message. Maybe Pak Ajun, you want to ask something? Please make it short, and Kubota Sensei also please shortly answer.
Okay, thank you very much, Mr. Ahli, Mr. Kubota Sensei. It's very interesting topic. We all know that the wood used is engineering wood, right? Such as glulam. We all know that kind of engineering wood have high performance behavior, resistant to loading, resistant to fire, and also to termite. And the quality assurance of this kind of structure is also maybe is well known, good from the fabrication and installation. However, I believe that the major concerns, it's not only about zero carbon perspective, it's also about cost. Do you already simulate about this one? And what is the competitiveness about this kind of structure with the other? Maybe that's my question. Thank you very much.
Thickness. That's also thank you very much. Thank you very much. That's also part of research, honestly speaking. The Singapore professor that I mentioned, his name is Mr. Professor Okuda. He is now an associate professor in NUS. He is, doing such research actually. So he's now trying to find the strengths and durability of such engineering, the building material used by using the tropical wood actually, like Falcata and also the Jabon. So I think we can make use of his data. So I will ask him to give us the specific the data of his experiment. I'm sorry, that is now it's now that ongoing topic actually. So Okuda, Professor Okuda also mentioned that he's still such a things is unknown. I mean, of course, that if we use the other material like pine and so on and so forth, we already know the strengths and so on and so forth, right? But for the tropical trees, still it is unknown. So therefore, I think that why don't we do the testing by ourselves, if possible, right? Together with the Professor Okuda. So if so, that research is quite important actually. So we don't know, honestly speaking. No one knows. So, right. It's interesting, right? That's it.
Okay.
Probability is unknown. So
Yeah.
that's very interesting.
Okay. Yeah. So how is Pak Jun? Is that clear enough, or you have any issue raising?
Okay, it's clear enough. Thank you,
Okay.
Mr. Kubota.
Thank you.
Thank
very
you.
much.
Yeah, we have 15 minutes left. So I already go through the questions. It seems most of the questions, not most, but some of the questions has a similarity in topics in questions. For example, the durability, endurance, structure, fire, and so on. And perhaps you already answers those questions. Yeah, probably about the fire prevention system. Yeah, you already mentioned in your presentation that one of the Japanese company has developed such a good fire retardant for the wood constructions, but I don't know, in the context of Indonesia, can be used in Indonesia, that system as well. Okay, that is some of question. I will try to summarize the question, and then perhaps with the remaining time, please respond one by one, Professor Kubota, because we have a limited time. So one is about the durability. You already mentioned from Mr. Adi and some of the participants. You already answered the question. Now about the fire, how we deal with the fire prevention system of the wooden structure in the apartment building. Probably we have to consider of the daily behavior of the occupants that might be effect on the fire hazards, since it will be used the fire, timber construction. Okay, some of them ask about the joining system of the wooden structures as a response of the seismic load. As you may know that Indonesia, just as Japanese, has experienced so many earthquakes, right? So that should be considered, and how you respond about that question. And then, again about the cost, the lifespan of wooden structure compares to the conventional ones. From Andi Hakim, Pak Andi from NTB, he concerned about the cost. How much the cost comparison from the conventional one and the lifespan, probably life cycle cost, probably, if I'm not mistaken. Okay, that's number 3 questions. Number 4, I think the question from Pak Hari Setiadi similar with Bu Gaisani about the impact on the environment if the demand increase. So probably, there will be some massively, I don't know, forest log. So that also will be influence our environmental issue. That's number 4. Okay, number 5. I think that's some issues. Okay, durability, you already answers the question. Okay, this is from the engineering physics about the use of the radiant cooling system. Could it be applied not only in apartment building but also in other buildings? For example, detached house, or maybe, he said conventional housing and so on. And in terms of initial cost, running cost, and maintenance, how is it compared to the conventional AC system? Thank you. So that's maybe 5 questions. I summarize from all the questions.
So good. Thank you, Raj, for summarizing. I think all of them are very critical questions. Thank you very much for, first of all.
Please, 15 minutes. I'm sorry.
Fire prevention. I think that some of you are, know better than me, honestly speaking. But in Japan, the fire, if I'm not mistaken, the first of all, the fire prevention, building code is the strongest in the world, in Japan, as you may know. Right. So therefore, the most important point first is how to say that which guidelines will we follow? Right, that's very important point. If we try to follow the Japanese fire prevention, regulation, for instance, the requirement is very, very high, right? But if we try to follow the local Indonesian, fire prevention code, perhaps the requirement is slightly lower, I believe, right? First, I think we should, discuss and determine which guideline will we follow, right? And then, if we try to follow the Japanese fire prevention, regulation code, it's a very tough, honestly speaking. So in that case, perhaps we may have to put the cement board on all the wooden structure, right? Otherwise, we cannot meet the Japanese regulation, right? So if so, okay, of course, it is costly, honestly speaking, and also the, aesthetically not beautiful, right? Because we want to see directly the nice wood surface, but we have to cover with the cement board, right? So we need to think how best to do that, right? But anyway, so that is really, of course, a very important question. Thank you very much. Right. And also, I'm sorry to say, in a way, this is our role, right? So I think that the testing by ourselves, that you have good facility, right? So I think the fire prevention and durability of the local tropical wood material. So these things are really important topic, actually, research. I think it's better to do it by yourself, right? So I'm sorry, that is right. And then the second one, the joint system also, this is, I'm sorry, I'm out of my expertise, honestly speaking. But if I'm not mistaken, yeah, the joint part is quite important, actually. Now we need to rely on the metal, the material, and then the most of the metal material come from the overseas, if I'm mistaken, Germany, if I'm mistaken. So therefore, actually, as long as we use such a metal joint parts, that will cost a lot and also consume a lot of energy, actually. So let's, try to find the best, way, joint, the method, right? So I think that, better to do it, locally, again, right? Without relying on the overseas, Germany and so on and so forth, metal parts, if we can find the, best way to join the, wooden parts, timber parts nicely, locally, I think that can reduce the cost again, right? And then the cost is, yes, as I mentioned, this time I think we need to forget about the cost, because we have to rely on the overseas. But as I mentioned very repeatedly, right, once demand is increased, right, once we, start producing, assembling the, material by ourselves in Indonesia, I believe we can reduce the cost dramatically. So that's a very important point, actually. So then, of course, we should use the local material and we should plant trees by ourselves. So if so, we can reduce the cost very much. So that is, yeah, thank you very much once again. Number 4, I just forgot. Do you have memo? Forest or something. Dr. Ariel.
Number 5 about the radiant cooling. Is it possible to be applied not only in apartment building but also in, let's say, conventional housings like the detached house or something?
Possible. Possible. I think
and how it costs compared to
Eh?
how about the cost compared to the conventional air conditioning system?
Yeah, of course, air conditioning, it's cheaper, much cheaper than the, this kind of cooling system so far. Again, this depends on the demand, right? Because everything is, most of the things depends on demand, honestly speaking. Now, let's say the PCM, for instance, is expensive. So at least, the 5 years ago, so when we conduct this, research, about more than 5 years ago. So, that we couldn't find the PCM in, the available in Indonesia. And therefore, we, imported the PCM from China to Indonesia only for the purpose of our experiment, right? It was costly, needless to say. But now, I don't know, perhaps some of the Indonesian company may produce the PCM by themselves, right? I don't know. But the
Okay.
right, so that everything is depends on the demand and also supply, right? So and then,
Yeah.
but PC actually it's not that cheap. I think better to make use of some some renewable material if possible in the future, so that we can reduce the cost actually, such as waste of oil palm or something, right? But anyway,
Okay.
so at the moment, we very much depends on the chemical material, so that's why a bit costly, honestly speaking.
Thank you very much, Kubota Sensei. We have 4 minutes left. So there are two comment actually from Sindu-san.
Okay, go.
Sindu-san. Sindu-san now is in Tokyo. So yeah, he just comment on if the design is for multi-tower, as you shown on the slide. Because previously you just saw like just single prototype, right? But you expected to be multi-tower, right? So many, yeah. Sindu-san only comment about we should consider about the performance of daylighting and also natural ventilation in the living room in particular. That is comment from Sindu-san. And from this is also interesting question. Probably you can answer short, very brief. Is there any government regulation in Japan that can be adopted in Indonesia regarding the use of wood as an alternative material for public buildings, especially apartments? Yeah, that's all. Only two. Yeah, I mean, do you have any Japanese regulation that can be adopted in Indonesia for this wooden construction?
Yeah, of course, yes. In a way, of course, yes. In a way, so as you know that have you been to the Tokyo, the Edo Tokyo Museum in Tokyo, for instance, right? As you may know,
I've been there.
One of the the crucial disaster in Tokyo was big fire. Needless to say, right? An earthquake and big fire was the major problem in the past, right? During the Edo era and also the early Showa, for instance. As you may know that yes, the Tokyo experienced the big fire several times. Some of them followed by the earthquake. Some of them are just fire. As you may know, and then the big fire destroyed the whole city sometimes, and major part of the city many times, and then many people die and so on and so forth. This is simply because at that time, most of the houses and also the buildings, most of the buildings were constructed by timber structure at that time in Tokyo. So therefore, that was very weak for the big fire. And then the fire destroyed the whole city many times, as you may know. And therefore, at the moment, the Japanese fire prevention, the building code is very, very strict. That's why, because of such a lesson, honestly speaking. So therefore, I'm not so sure whether we should follow such a very, very strict, the Japanese restriction and adapt it to Indonesia or not. That I don't know, honestly speaking. But of course, I believe, that I think we can learn, a lot from the Japanese experience.
Thank you. And how about the Sindu-san comments? Do you have any comments? Hello? Can you hear me? Can you hear me? Hello? Professor Kubota? Can you hear me? How about the Sindu-san comments? We have to consider about the ventilation on the living room and also.
I'm sorry. Yeah, true. Of course, true. Thank you very much for the nice comments. Needless to say, yes. But for the living room, but in a way, if we ventilate a lot, indoor temperature will be increased actually. So therefore, of course, we should exhaust the heat. So therefore, some ventilation is needed. But if we ventilate very, very fully, in a way that will increase the air temperature. So therefore, there's a trade-off actually, as you may know.
Okay. Thank you very much. I think we are running out of time. So Thank you very much once again, Professor Kubota, for
Oh.
very nice presentation and very interactive conversation and Q&A session. And I believe we are all enlightened with your presentation and also your presentation. Very nice indeed. Thank you very much for this is just from the organizer. Please, you might choose two best questions.
Oh, difficult. Oh my God.
Yeah. Oh, best
That's
comment, best comment. Because we will give some souvenir for the best comments.
Oh, okay.
Maybe you can select
good.
which comment, and then we find who asked the comments. Ask the question.
Wait,
To
no.
you? Yeah.
Hey, I think, oh my goodness, honestly speaking, this time I think I was really impressed all the comments and questions. So I think it's a very difficult to rank. Honestly, every comment was good. Honestly, I'm sorry.
Okay, I just pick randomly.
Really, honestly speaking, weight is same. Every comments question is perfect.
Or maybe you can inform us later. Panitia gimana? Atau harus sekarang?
Mungkin bisa sekarang.
Okay, the organizer request me to ask you right now. Sumimasen. Right now, you have to right now.
Oh, it's difficult because it's impossible to everything right.
Okay,
So
kalau gitu saya yang milih aja ya. Boleh?
Iya, boleh.
Yes.
Okay, on behalf of Professor Kubota, so I will select the best, the best questions from all of the participants. So, the good questions about the environmental impact of the wooden structure of the demand. So I gladly announce that from BPP Jawa Timur, I forget Kaisani. Is it okay, Professor Kubota?
Yes.
Okay. And also from, I think, about the termite, I think, and so on, also very good from Ivan, I think. Very good. So congratulations, Professor Kubota. Actually, we have a souvenir for you as token of appreciation from us because you are giving this very nice lecture. But unfortunately, if we were do it online, so we can give it directly to you. But since you are now in Jakarta and I'm in Malang and others in Bandung, so we are sorry we cannot give it to you right now. So perhaps if you visit Indonesia again, so we will give it to you as a token of appreciation from us, from Balai side.
Okay.
So thank you very much. Now my assignment, my task is already over. Is over to chair this session. Thank you very much for Kubota Sensei and all the participants for attractively involved in the very joyful discussion. Thank you very much. And I think I don't need to summarize anything because I think we already know what have we discussed today. Once again, thank you very much, Professor Kubota and Omedetou gozaimasu. Congratulations for the two best questions, and also from all the participants, the director of SSPP, Pak Edward, also very much thank you for your attendance, Pak Agung, and I also see some colleagues outside of the PUPR, Bapak Ibu dari PUPR semuanya, terima kasih banyak atas kehadirannya. Thank you very much. I now give the screen to the organizer. Thank you.
Oke,
Silakan,
baik.
Bu Inat.
Ya, baik. Terima kasih Pak Ariel sebagai moderator dan narasumber kita, Profesor Tetsu Kubota, atas paparannya yang sangat-sangat menarik dan bermanfaat. Mungkin ingin tanya dulu nih testimoni dari Mbak Gaisani atau Bu Gaisani, bagaimana tentang acara bimbingan teknis sains dari Balai Sains Bangunan saat ini? Boleh testimoninya, Bu?
Iya, terima kasih Mbak atas kesempatannya. Yang saya sangat senang dari bimbingan teknis kali ini materinya sih Mbak. Materinya sangat ini ya, sangat menarik tentang tujuan kita untuk melindungi lingkungan seperti itu, dan narasumbernya juga sangat menarik, Profesor Kubota. Terus panitianya juga secara keseluruhan menyelenggarakan BIMTEK ini sudah dengan sangat baik seperti itu. Itu aja sih Mbak. Terima kasih banyak atas penyelenggaraan BIMTEK kedua ini. Itu Mbak. Terima kasih.
Iya, ya baik. Terima kasih Bu Gaisani atas testimoninya. Ditunggu ya BIMTEK bimbingan teknis sains dari BSB selanjutnya. Selamat juga untuk Bu Gaisani sebagai pemenang dari pertanyaan terbaik bersamaan dengan Bapak Ivan. Oke, mungkin kita sudah ada di penghujung acara ya. Acara selanjutnya yaitu pengisian form responsi yang terdiri dari kuesioner, post-test, serta presensi. Jadi diharapkan untuk seluruh peserta untuk mengisi kuesioner ini ya, seperti itu. Nah, untuk batas waktu pengisian form responsinya sendiri itu selama 30 menit. Jadi form responsinya akan ditutup pengisiannya pukul 12 waktu Indonesia Barat nanti. Nah, perlu diketahui juga bahwa pengisian form responsi ini merupakan salah satu syarat yang digunakan agar para peserta dapat mendapatkan surat keterangan elektronik. Sebagai penutup kegiatan bimbingan teknis sains hari ini, penutupan akan dilakukan oleh Kepala Balai Sains Bangunan, Bapak Ajun Haryono, STMSCN. Kepada yang terhormat Bapak Ajun Haryono, kami persilahkan.
Baik, terima kasih Bu Inat. Dear Honorable Professor Tetsu Kubota from Hiroshima University, Japan, Director or their representative from Directorate General of Human Settlement and Directorate General of Housing, Head of BPPW and BP2P, and all participants. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Alhamdulillah, all praise belong to the God. We all have gone through all of the session today successfully. Indeed, the session was very interesting and insightful. And I believe we have received so much valuable knowledge from Professor Tetsu Kubota. I hope what we got today is very useful and enlighten us on how to achieve sustainable development goals. Furthermore, I also really hope that this event also would widen our perspective, at the same time sharpen our approach on how to use wood as sustainable material for building in Indonesia. A lot of challenges we face in the future, particularly in the building sector, and those challenges require innovative ways to overcome. Now we understand that there are at least 3 pathways to reduce energy consumption: lower the demand and use less energy, and more efficient use of energy, and substitute fossil fuel with renewable energy sources. Despite advanced material technology, we in Indonesia have a traditional material that has been used for centuries: woods. Traditional houses, which are mostly constructed of timber, perfectly adapted to the tropical hot and humid climate and provided better indoor thermal environment. It is undoubtedly the most sustainable material on earth. That's why the wooden material has recently been developed for high-rise building. distinguished guests and ladies and gentlemen, as a closing remark, I would like to give million thanks to Professor Tetsu for giving such a nice and insightful lecture in this section. I do really appreciate it. I hope we can further collaborate in the future. And I hope you can enjoy time in Indonesia, particularly in our campus in Bandung. Thank you very much for all participants who attend offline and online and stay in this program from beginning to the end. I do really hope what we organize is beneficial and inspire all of you. At least by reciting Alhamdulillah, I hereby officially close the session today. See you again in the next session. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih Bapak Jun Haryono atas closing remarks-nya. Izin mengingatkan kembali untuk para peserta, jangan lupa untuk mengisi form responsi yang linknya sudah disertakan oleh panitia di kolom chat. Jangan lupa untuk pengisiannya sendiri itu sampai pukul 12 waktu Indonesia Barat. Dengan disampaikannya penutupan dari Kepala Balai Sains Bangunan, maka berakhir pula acara kegiatan Bimbingan Teknis Sains hari ini. Saya Inat, selaku pembawa acara, menyampaikan permohonan maaf apabila ada perkataan dan perbuatan yang kurang berkenan. Mari kita akhiri kegiatan ini dengan bersama-sama mengucapkan hamdalah. Alhamdulillahirabbil alamin. Nah, sebelumnya ada pantun sedikit dari kami panitia. Beli tempura sama Pak Profesor Kubota. Sampai jumpa di BTS selanjutnya. Terima kasih atas partisipasinya untuk seluruh peserta. Semoga kita bisa bertemu kembali dalam acara bimbingan teknis selanjutnya. Tetap patuhi protokol kesehatan dan jangan lupa jaga kesehatan juga. Saya Ina dan segenap panitia pamit undur diri. Salam prima. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Mengurangi Luruslah jalan Payakumbuh, babelok jalan kayu jati, di mahati indak karuswah, ayam dan lape, ayam dan lape. Mendaki jalan pandai sikit, menurun jalan kabiaro, di mahati indah kamau pe, awak taki cua, ayam dan lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju nan karimbo, oi lama juo. Pagaruyang batu sangka, tampe bajalan urang baso, duduk taman uang biok sabata, oi takana juo, ayam dan lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju nan karimbo, oi lama lang juo. Pagaruyang batu sangka, tampe bajalan urang baso, dudua taman uang tiok sabanta, oi takana juo. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju nan karimbo, oi lama lang juo. Pagaruyang batu sangka, tampe bajalan urang baso, dudua taman uang biok sabanta, oi takana juo, ayam dan lape, ayam dan lape. Cicik periuk bilang asumbing dari Jawa, datang dek ke Cibok bawa kepiting 2 ekor. Cicik periuk bilang asumbing dari Jawa, datang dek ke Cibok bawa kepiting 2 ekor. Cak udah bilang bijak hidung gigi ronga, sampai kita wadolo di Tanjung Raja Tunggal. Tuhan memang sengaja untuk menghibur hati nan duka. Burung dara, burung merpati, terbang cepat ya Tuhan, tiada tara. Bilalah kita ya Tuhan suka menyanyi, badanlah sehat ya Tuhan, hati gembira. Oh, buah mangga enak rasanya, si mana lagi ya Tuhan paling ternama. Siapa saja ya Tuhan rajin bekerja, pasti menjadi warga berguna. Burung dara, burung merpati, terbang cepat ya Tuhan, tiada tara. Bilalah kita ya Tuhan suka menyanyi, badanlah sehat ya Tuhan, hati gembira. Kecil-kecil ini lagu rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Mana kancil akan dikejar ke dalam pasar, cobalah cari. Masih kecil rajin belajar, sudah besar senanglah diri. Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Hey! Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Kalau ada sumur di ladang, boleh kita menumpang mandi. Kalau ada umurku panjang, boleh kita jumpa lagi. Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Rasa sayange, rasa sayang sayange, lihat dari jauh rasa sayang sayange. Tokecang bala gendir, tosbong angen kacang sapariuk kosong. Tokecang bala gendir, tosbong angen kacang sapariuk kosong. Biaya listrik di masikit, manica angkat tinggalna, ayah istri jangkung alit. Karangan dina pipina, tokecang bala gendir, tosbong angan kacang sapariuk kosong. Tokecang bala gendir, tosbong angan kacang sapariuk kosong. Anjuau, say anjuau, ale anggi. Dinamuruk manang marsa, rohanggi. Nang sohu baboa, asakna di roha, holong ni rohangku, say hotoi. Anjuau, say anjuau, ale anggi. Engkel mi mambahen pasona, rohanggi. Tung saleleng ahu di lambung mi. Anjuau, say anjuau, ale anggi. Nang sohu baboa, arsakna di roha, holong ni rohangku, say hotoi. Anjuau, say anjuau, ale anggi. Engkel mi mambahen pasona, rohanggi. Tung saleleng ahu di lambung mi. Anjuau, say anjuau, ale anggi. Oh, anjuau, say anjuau, ale anggi. Luruhlah jalan payakumbuah, babelok jalan kayu jati, di mahati indak karuswah, ayam dan lape, ayam dan lape. Mendaki jalan pandai sikit, menurun jalan kabiaro, di mahati indah kamampe, awak taki cua, ayam dan lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju nan karimbo, oi lama juo. Pagaruyang batu sangka, tampe bajalan urang baso, duduk taman uang biok sabata, oi takana juo, ayam dan lape. Lamalang juo Pagaruyuang batu sangka Tampe bajalan urang baso Dua taman uang tiok sabanta